Solids can be crystalline, where they are arranged in a repeating three-dimensional structure, or they can be amorphous, where the particles don't have a regular, orderly arrangement. And in both cases, the motion of the individual particles are limited, so they don't undergo overall translation relative to each other. So here is an example of a crystalline solid with a body-centered cubic arrangement. And this is an allotrope of iron, which is called alpha iron. And an allotrope is really different structural modifications of an element, such as with diamond or graphite, where carbon is arranged in a 3D or multi-layered arrangement. And under normal solidification conditions, metals and ceramics have a crystalline arrangement. And the structure of a solid is influenced by interparticle interactions and the ability of the particles to pack together. So for example, in metals, you have metallic bonding, where the core particles are arranged with free valence electrons, and there's no restriction on the number and position of the nearest neighbor atom, which leads to dense atomic packing in metals. And another example is crystalline silica, or silicon dioxide, and this structure is stacked in several layers. So out of the plane, you may have something like this. So effectively two oxygens bonded to each silicon. And here is an example of amorphous silica, which is also silicon dioxide. And you can see that the structure is not regular over large interatomic distances. And these are used in different applications.